Hi, welcome to Physical Science Lesson 2.2b. This is more on the impulse-momentum relationship. An example that you have already done in your assignment is 100 Newton force is applied to a 5 kilogram mass for 1.5 seconds. The mass starts from rest. What is the impulse? Well, the impulse is the force times the time, so 100 times 1.5 is 150 Newton seconds. What is the change in momentum? Change in momentum is equal to the impulse, which is 150 kilogram meters per second. We changed from impulse to a change in momentum, and we changed the units. What is the initial momentum if it starts from rest? Well, a change in momentum, the initial momentum would have been 0 kilogram meters per second. Final momentum then would have been 150 kilogram meters per second. What would the final velocity then be? Final velocity would be momentum divided by mass, which is 150 divided by 5, or 30 meters per second. Lots of things that you can find from one set of information. In this simulation, which I will show you in class and give you access to, it is on the PhET website. From this simulation, you can use the given information to find the mass of the objects, the time to get from here to 0, or to get here from 0, the impulse, and actually show the change in momentum in two ways. In that situation, you're given a net force of 207 newtons, a change in velocity of 10.2 meters per second, and an acceleration of 1.38 meters per second. From that, we can find the mass, the time, the impulse, and then the momentum or change in momentum in two ways. First, let's find mass and time. Mass from 1.3 is force divided by acceleration. The force was given as 207 divided by 1.38 gives us a mass of 150 kilograms. Time from 1.2 is a change in velocity divided by acceleration. So time is 10.2 divided by 1.38, or 7.39 seconds. Impulse is force times time. So force of 207 times a time of 7.39 gives us an impulse of 1,529.73 Newton seconds. The change in momentum, the first way to find it is to realize that it is equal to the impulse, 1,529.73 kilogram meters per second. The second way to find impulse is the mass times the change in velocity. The mass was 150, the change in velocity from 0 to where we were was 10.2, giving us an impulse of 1,530 kilogram meters per second. The only difference between those two answers is what's called a rounding error, because we used rounded values to find some of our final calculations. Otherwise, this should show that the change in momentum is the same no matter how you calculate it. Thanks for watching.